So let's take a look at number 2a. Here they're asking you to complete the diagram below to show the resultant of the two given forces. So here's the box being pushed. Here's your first force. It's worth, so this is F1, and its magnitude is equal to 220 newtons. And here's your second force, something like this. This is force 2, and its magnitude is equal to 375 newtons. Now here's the horizontal. Try to make it as straight as possible. This angle here we see is 30 degrees, and this angle here we see is 340 degrees. So inside here, there's 20 degrees missing to make it a full circle. So this inside angle here is 20 degrees. When calculating the components of this vector here, of F2, it'll be useful to know this inside angle. In fact, let's try to find the components of this right now. The x component here is going to be equal to 375 times, so adjacent over hypotenuse, that would be cosine of 20. Let's pull out the calculator. So 375 times cosine of 20 equals 352. So this is 352.4, and the y component is equal to 375 times sine of 20. And with our calculators, we do 375 times sine of 20 equals 128. But this 128 is in the negative direction, so negative 128.25. So these are the components now of F2. I'll write that down over here. F2 vector equals component, x component is 352.4, and the y is negative 128.25. Now let's take a look at the F1 vector and its components. So its y component I'll write up here. This is the y component over here, the vertical. It's equal to 220 times, opposite over hypotenuse, that's sine of 30, and that'll give us 110. And the x component is 220 times cosine of 30. Let's pull up the calculator for this. So that's 220 times cosine of 30 equals 190.53. So that's 190.53. Now I'll write F2 down here. F1. That's equal to, the components are 190.53, comma, y component is over here 110. So now we have the two vectors, and had I wanted to complete the diagram, I would have made a parallelogram like this, something like this, and then the resultant vector would have been this one here across. That would have been your resultant vector. But algebraically, we find the components of this resultant vector. Now this sketch might be not to scale. It's possible that, in fact, it's very likely that this vector is below the horizontal, because we see that this bottom vector is bigger than this one over here. So this is just badly drawn. But the algebra behind this will save us, and the resultant R is equal to, and now we add these two F1 and F2 vectors together, component by component. Now, the x components together is 352.4 plus 190.53. That gives us an x component of 542.93. And the y components, when added together, it's 110 minus 128.25. So 110 minus 128.25 gives us negative 18.25. So here you have it. Here's the resultant, and as you can see here from the negative, we have a vector that kind of looks like this. So if this is my horizontal, then I've got this kind of resultant here, where the vertical is negative 18.25, and over here the horizontal is 542.93. Now finding the magnitude of this is as easy as Pythagoras. So magnitude of r equals 542.93 squared plus negative 18 in brackets, 18.25 squared, and all that square root. And with our calculator, we see that this is equal to, so 542.93 squared plus negative 18.25 squared equals, and then I square root that, it gives me 543.24 units in magnitude. And now finally for the angle, this angle over here, let's color it pink so that it's clear, this angle over here, theta. Theta is equal to the tan inverse, tangent because I know the opposite and the adjacent sides, so tan inverse of opposite, negative 18.25, over, so 542.93. Now, actually the way I've set it up, because I put a negative in here, it won't give me the theta inside. It'll give me this angle here. So this is actually what theta is. So I'm going to cross that out. There's our theta. This is the exact value we're looking for with respect to the horizontal in the positive direction, so the counterclockwise direction. And on our calculators, let's pull out the calculator, we do 18.25 negative divided by 542.93 equals, and now let's take the tangent inverse of that. It gives us negative 1.9 degrees. Negative 1.9 degrees. So approximately negative 2 degrees. Now I made a little mistake again. So negative 2 degrees is in this direction here, in the negative direction. So this whole thing here is 360 degrees minus 360 degrees minus these 2 degrees, and that's 358 degrees in orientation. So this here is 358 degrees.